Okay, this is how to make a graph for your time to stabilization condition. Um, again, what we're looking at here is our z-axis, so that's measured in newtons. And then we have our sequence. What this represents is the time of event and number of events that occurred for our measurements. So how do I say that again in a different way? Every single one of these events in the sequence is 1/1000th of a second difference in which these measurements were taken. So for example, this is at our 0 mark. This is 1/1000th, 2/1000th of a second, 3, etc. Now, in order to see our force over time, we're going to have to make a time column. So again, we don't want our sequence or number of measurement events, which is what we have here currently in column A. So yeah, to do that, we just go insert. This can now become our time, and time is of course in seconds. And we just create a little formula where it goes equal whatever event number we have here in our sequence, and then we go divided by 1000. Once you have that, you can hit enter. And to auto-populate all the way down for all of these event measurements, we just wait till our crosshair icon goes from kind of bolded down to the black, and we double left click, and that should auto-populate all the way down. So again, what this is saying is this is 0.009 of a second, full second. Okay, so you can see the frequency or the hertz of measurement is 1000. That means, again, every 1000th of a second we get a measurement in our force. Okay, great. On to the graph. So once we select fully our C column, we can head on over to insert, and we are going to go to our line graphs. Now we'll just have our 2D line graph here, because again, we want force over time as a continuous line measurement. We're going to select that, and there we are. We have our graph populated and made. Now, again, if we kind of try to interpret what's going on with the graph, we have a lot of time where nobody is on touching the force plate, then when someone has landed, and then some amount of time where we have some stabilization occurring. So one of the things that you will want to do with this graph is trim it. So you'll want to get to the point in time where you only have readings from the landing onward. And in fact, you can trim it all the way to peak force or just before any force actually is applied to the force plate. Either of those are fine. Again, we're really looking for the time it takes from that landing to the point of stabilization, which for some people might not occur at all within this period of time. Sometimes it'll occur within a few seconds. Okay, so that is one thing you can do to trim the data. Essentially, you just delete all cells and events that occur prior to the force landing that you want. So again, you might need to look at the event or x-axis to figure out where to do that, or you can maybe reverse engineer it and look at, okay, on our z-axis, the peak is around 3000. So essentially you go all the way down, and again, you have to cruise down here a little bit to get to the point where you see some above, let's say, 3 newtons sort of thing to indicate that that's where this landing is starting to occur. Okay, before we get to that trimming of the data, we can come back to that. We have one issue, whether you decide to do that or not, is this right here. So again, this x-axis has auto-populated our B column. And so we can see it goes up to 4,800. It actually probably is 5 seconds long, so it goes up to 5,000. So in order to get the right data here, and I hope the window works, we're going to we're going to right click on that, and it's just out of the field. So let's see if I can change this so you can see it. There we are. So you're going to right click there and go select data for that column. Okay. Once you've selected data, we want to go to our horizontal axis here, make sure that we're plotting it correctly. And as you can see, it's selecting this. So we simply go click that. So that was a left click, hold select, and we want to go down to the bottom. So to do that so quickly, I hit Shift, End, and down, and it just got all the way to the end, selecting just the numbers and the seconds. I did not select the header of time. Otherwise, I'll mess up your data. Okay, so once you have that selected all the way down, again, we're just selecting our seconds. We're going to go to OK. And now you can see in purple, we have our time column in seconds selected. Excellent. And then our Z in newtons on the right here. And just to note, as far as the numbers, depending on how many seconds it went, you'll see 4, 5 seconds, sometimes 7. Again, it depends how long we ran your data for. And again, you can trim all of this extra data if you want, if it's irrelevant to what you're trying to measure. Or you can just leave it in if you feel that works for you. So again, you just want to include the amount of time to stabilization, which might only be 1 second, maybe 3. But again, if you have extra that isn't actually included in your time to stabilization, you can trim that if you wish. Okay, so there we are. We now have seconds on the bottom and newtons on the left here. So we're feeling good about that. The one last thing that we'll want to do is to bring it a little bit more in line with APA is double click this chart title here. And I don't know if this is which condition this is. So I'm just going to say 2 foot time to stabilization. Okay. And there we go. And then that's at least the initial starting point for you and your graphs. Again, you might want to have someone come in and trim this data so you can more readily see exactly what the time to stabilization was. Okay. And oh, most importantly, before you exit, if it's not already in an Excel format, it might be in a CSV file format. You simply go Save As and then select the type of workbook you want. So file format, here we are, Excel workbook. You do not want this CSV comma delimited. Otherwise, the graph will not save. So Excel workbook, great. Save. I'm going to replace it because now we have this graph. Okay. And that is it for the time to stabilization.